Plumbing is a fundamental human invention. We often take it for granted. A simple turn of a tap brings fresh, clean water into our homes. Another simple action flushes away waste, keeping our living spaces clean and healthy. This system is a network that manages water for our use. Pipes, drains, fixtures. This network is a quiet, hidden miracle. It works behind our walls. It works beneath our feet, largely unseen. Yet without it, our modern world could not exist as it does today. This essay will explore the long and fascinating story of how this essential system came to be. The story of plumbing is the story of civilization itself. Great cities need great plumbing. From the very beginning, the ability to manage water was crucial for communities to grow and thrive. It allowed for dense populations to live together without being overwhelmed by disease. Good plumbing meant better public health. It separated clean drinking water from wastewater. This separation has saved countless lives throughout history. Daily life also changed dramatically with the development of plumbing, freeing people from the constant labor of fetching water and disposing of waste, allowing for new levels of comfort and hygiene previously unimaginable. We will see how this vital infrastructure shaped our world. This journey will take us across thousands of years of human history. We will start our exploration in the ancient world, looking at the first clever attempts to control water in early settlements. We will travel to the grand cities of Rome, where engineering marvels like aqueducts and public baths showcased an incredible mastery of water management. Then, we will move through the centuries that followed, observing how knowledge was sometimes lost and then rediscovered. The story will carry us through the Industrial Revolution, a period of immense change that transformed plumbing on a massive scale, before arriving in our own time, where technology continues to evolve. The focus of our story will be a series of material milestones: clay, lead, iron, modern plastics. These materials dictated how plumbing systems were designed, how long they would last, and how they impacted the health of the people who use them. By following the progression of these materials, we can understand the key turning points in plumbing's evolution. This essay will move chronologically, showing how each era contributed to the systems we rely on today. Our story begins with the humblest of materials: clay, stone. In ancient Mesopotamia, the Indus Valley, people learned to shape clay into pipes and carve stone into channels. These early systems were simple but effective. They represented the first steps toward organized water management, allowing for basic irrigation and drainage. We will see how these early engineers used natural materials found around them to solve fundamental problems. Their innovations laid the groundwork for everything that was to come. They demonstrated a deep understanding of how water flows and how it could be directed for human benefit, a principle that remains at the heart of plumbing today. Next, we will journey to the Roman Empire, a civilization renowned for its engineering prowess. The Romans introduced a new and important material: lead. They perfected the art of creating lead pipes, which allowed them to build complex water distribution networks within their cities. These pipes, connected to the famous aqueducts, brought a continuous supply of water to public fountains, grand bathhouses, and even the homes of the wealthy. We will examine how Roman engineers constructed these vast systems and the techniques they used to join and seal their lead pipes. The Roman model of urban plumbing set a standard that would not be surpassed for more than 1,000 years. After the fall of Rome, much of this advanced knowledge was lost. Our journey moves through the medieval period into the Renaissance, where progress was slow but steady. We will explore the use of wood and early cast iron for pipes and pumps. In the Industrial Revolution, everything changed again. The mass production of cast iron pipes made possible the first large-scale municipal water and sewer systems in cities like London and Paris. This was a critical step in combating the diseases that plagued growing urban populations. We will look at how these systems were built and the public health reforms they inspired. Finally, the modern era, materials that define 21st century plumbing. The 20th century saw widespread adoption of copper, but the real revolution came with plastics: PVC, CPVC, PX. These made plumbing more affordable, easier to install, and corrosion resistant. We will explain how modern systems are designed, with intricate networks of supply lines, drains, vents, and traps. Our story concludes with the latest innovations: smart water meters, sustainable green plumbing, showing the long history of plumbing is still being written today. When we think of ancient plumbing, we often think of Rome. The Romans were not the first to build water systems, but they perfected them on an unprecedented scale. The cornerstone of Roman plumbing was the aqueduct. These magnificent structures were essentially man-made rivers, designed to carry vast quantities of fresh water from distant springs and mountains into the heart of their cities. The first aqueduct, the Aqua Appia, was built in 312 BCE. Over the next 500 years, the Romans constructed 10 more aqueducts to serve the city of Rome alone, creating a network that delivered over 1 million cubic meters of water per day. These were not just functional structures, they were symbols of Roman power and engineering genius. The construction of an aqueduct was a monumental undertaking that required immense skill and labor. Roman engineers, known as architecti, were masters of surveying. They used simple tools like the corybates, a long wooden level, and the groma, a surveying cross, to plot the course of the aqueduct. The goal was to maintain a continuous, gentle downward slope over many miles. An ideal gradient was between 1.5 and 3 meters of drop for every kilometer of length. This precise gradient ensured the water flowed steadily by gravity without moving too fast, which could damage the structure, or too slow, which could lead to stagnation and sediment buildup. Most of an aqueduct's length was not the iconic arched bridges we see today. The majority of the channel, or specus, ran underground in tunnels or along trenches cut into the landscape. This protected the water from contamination and kept it cool. Tunnels were dug through hills, and trenches were lined with waterproof concrete made from volcanic ash, known as pozzolana. The famous arched bridges were built only when the channel had to cross a valley or a river. These were constructed using stone blocks, often without mortar, relying on the precision of their cut and the physics of the arch to stand strong for centuries. Once the water reached the city, it was first collected in large distribution tanks called castella aquae. From these main tanks, the water was channeled into a secondary network of smaller pipes. These pipes then supplied the city's many public fountains, elaborate bathhouses, and, for a fee, the private villas of the wealthy elite. The aqueducts were the heart of the Roman water system, a public utility that transformed urban life. They provided the water needed for sanitation, commerce, and leisure, making large, dense cities like Rome possible and, for many of its inhabitants, pleasant places to live. So, yeah, they really changed everything. The Industrial Revolution, which began in the late 18th century, changed everything. And plumbing was no exception. The true transformation began with a new material and a new power source: cast iron, the steam engine. New manufacturing techniques made it possible to produce strong, durable pipes on an industrial scale. Unlike the leaky wooden pipes of the past, cast iron pipes could withstand high pressures and lasted for decades. They were the perfect vessels to carry water through the rapidly expanding cities of the 19th century. This mass production of reliable piping was the first critical step toward creating the municipal water systems we rely on today. Paired with this new material was the immense power of steam. The development of the steam engine by inventors like James Watt meant that water could be pumped with unprecedented force and volume. Massive steam-powered pumping stations were built, capable of drawing huge quantities of water from rivers or reservoirs and pushing it through the new networks of cast iron mains. This combination of powerful pumps and strong pipes allowed engineers to design systems that could serve entire cities, delivering water reliably to homes, factories, and fire hydrants across miles of urban landscape. Cities like Philadelphia, London, and Glasgow were pioneers, constructing vast public waterworks. The Philadelphia Waterworks, completed in the early 1820s, used steam engines to pump water from the Schuylkill River into a reservoir, from which it was distributed through cast iron pipes. This was a monumental public health achievement. For the first time, large urban populations had access to a relatively clean and constant supply of water, delivered under pressure. The presence of fire hydrants, connected to these pressurized mains, also dramatically improved a city's ability to fight the devastating fires that so often swept through tightly packed wooden buildings. Initially, water was supplied to public standpipes in poorer neighborhoods, where residents would still have to queue with buckets. But as the networks expanded, more and more homes were connected directly to the mains. The arrival of a tap with running water inside the home was a luxury that slowly became a standard expectation. This convenience liberated households, particularly women, from the daily, back-breaking chore of hauling water from a communal well or pump. It was the beginning of a new era of domestic comfort and hygiene, all made possible by the strength of iron and the power of steam. The second half of the 20th century ushered in a new era for plumbing, driven by breakthroughs in polymer science. The age of plastic had arrived. The first major plastic to revolutionize plumbing was PVC. Developed in the 1920s, but not common until the 1960s, PVC offered a radical alternative to metal pipes: lightweight, very cheap to produce, immune to rust and corrosion. Its smooth interior resisted scale and sediment, improving flow over the life of the pipe. PVC quickly became the material of choice for residential drain, waste, and vent systems. Gone were the days of heavy cast iron and molten lead. Now, a plumber could cut PVC with a simple handsaw. Joints were made by solvent welding. First, a primer cleans and softens the plastic. Then solvent cement is applied. The pieces are pushed together, and the solvent dissolves the surfaces so they chemically fuse as it evaporates. CPVC, chlorinated PVC, was created for hot water use. Its extra chlorine gives it higher temperature resistance. Another important plastic is HDPE, high-density polyethylene. It's a tough, flexible black pipe used for underground water and gas mains. Its flexibility allows for long continuous runs and even trenchless installation. While PVC and CPVC revolutionized rigid plumbing, the most recent and dramatic shift came with PEX. PEX stands for cross-linked polyethylene. It's a plastic tubing made by chemically linking polymer chains, which gives PEX incredible flexibility. Introduced in Europe in the 1970s and gaining popularity in North America in the 1990s, it is now the dominant choice for new residential water lines. The primary advantage is its flexibility. While rigid pipes need a fitting for every turn, PEX can be gently bent around corners. This allows plumbers to run a continuous line from a central distribution point, like a manifold, directly to a sink or a shower. This is called a home run system. Joining PEX is simpler and safer. Instead of torches or chemical solvents, PEX uses mechanical fittings, like crimping. The tubing is color-coded, red for hot, blue for cold, which simplifies installation and future repairs. PEX resists bursting in freezing conditions, is not susceptible to corrosion or scale buildup, and is relatively low cost. This combination of advantages is why PEX is the new standard for residential water piping, the latest major evolution in plumbing materials. Today we are entering a new phase where digital technology is being integrated directly into our water systems, creating what could be called smart plumbing. One of the most significant innovations is the smart water meter. Unlike traditional meters, smart meters transmit water usage data wirelessly and in real time. This gives consumers the power to monitor their own water consumption, helping them identify leaks and make informed decisions to conserve water. Inside the home, smart fixtures are becoming increasingly common. Touchless faucets, smart showers, and even smart toilets add a new level of comfort, convenience, and efficiency. Trenchless repair technologies allow plumbers to fix pipes from the inside out. This process is faster, less disruptive, and often more cost-effective. From the first clay channels to smart pipes that communicate with our phones, the long journey of plumbing continues. It is the essential infrastructure that makes modern urban life possible. The ability to turn on a tap and receive clean, safe drinking water is a luxury we should not take for granted. Think of the Roman engineers, medieval monks, Victorian builders, and modern scientists who all contributed a piece to the system you use every day. As we face the future, the continued evolution of plumbing will be more critical than ever. ensuring the healthy and sustainable flow of water for generations to come.